It's down, and we'll get to them, I promise, okay? But let's start with our notes first. Midpoint and distance formula. This is where you're going to want to be super careful, write neatly, because there are lots of places you can make a mistake on this section, okay? But if you're writing your work really neatly, then you'll be fine. Coordinate plane. So today we do go back to Algebra 1. We talk about two-dimensional XY axis. Your coordinate plane was created by Rene Descartes. He was the mathematician that developed the coordinate plane. And your coordinate plane is a plane that is divided into 4 regions. So let's see how much you remember from Algebra 1. Where is quadrant 1? Top right. Okay, where's quadrant 2? Top left. And then we go counterclockwise, right? So this is the 3rd quadrant and the 4th quadrant, because you will have to identify on your homework which quadrant it is based on certain questions they ask. Okay, what is the x-axis? Okay, the horizontal one, so this is your x, and that means the vertical one is your y-axis. And these are arrows going on forever, okay? In Algebra 1, you did talk about writing an ordered pair as x comma y, so just make sure you're always putting your x and then your y when you are locating a coordinate. So the next thing we're going to do is talk about the midpoint formula and where the midpoint formula comes from. This is crazy. So this right here looks a little stressful. So instead, we are going to, I'm going to draw it up here on the board just to kind of demonstrate it a little easier, okay? So here is my XY coordinate plane, really sloppy. And let's say that I have a line segment on my XY plane. So this point right here, I'm just going to call X1, Y1. This point, then I'm going to call X2, Y2. Everybody okay with that? If I want to find the middle point between X1, Y1 and X2, Y2, I can use the idea of averaging. The average of something is the middle of it. So if I'm trying to find the middle X value and the middle Y value, then all I have to do is add my 2 endpoints. So to find this midpoint here, I'm just simply going to add the x1 plus the x2, and to average, what would I divide by? 2, because there's 2 of them. That's going to give me my middle x coordinate, and then I'll do the same thing for the y value. I'll take my lowest y and my highest y, so y1 plus y2, the 2 endpoints, and then just divide them by 2. And that is your midpoint formula. It is just simply the average of your x's and the average of your y's. Does that make sense? Okay, so the very first formula that you need to memorize is your midpoint formula. This should have an equal sign in between there. It was too close to it there. So that should say M equals capital M for midpoint, because remember that we use a capital letter to name a point. Our lowercase m typically means slope when we're dealing with writing an equation of a line. But a capital M stands for midpoint, or a point on your graph. Okay, so if we go to our midpoint formula song, turn to your red paper. All right. Okay, so we're going to do midpoint first. This is the one that's too itsy bitsy spider, okay? And I have it memorized, but it makes me a little nervous to sing in front of you. And here's what's really bad is I'm recording. So not only am I singing it, but now it's recorded. So last year when I did this, my son would like haunt me at home by playing the video of my voice on, it's terrible, stop it. Okay, so here we go. Yes, and remember, you have between now and Thursday, which isn't a lot of time, but you can get as creative as you want. It has to have the words to the formula though, okay? But you can, it doesn't necessarily, if you came up with your own version, but it was the formula in your own version, it would be fine. You may want to send it to me just to be sure. But you can be as creative as you want. Play an instrument as long as you can still sing, play your guitar, whatever you like. But you do have to sing it, okay? So here we go. I'll sing it once, and then we're all going to sing it together. Okay, here we go. When finding the midpoint of 2 points on a graph, add the two x's and cut their sum in half. Add up the y's and divide them by a 2. Now write them as an ordered pair. You've got the middle of the 2. There you go. Okay. It's that. You ready to do it with me? Yes. We got to practice now. Okay. Okay. I'm nervous, so I had to sing it fast. But we can go slower. All right. You ready? Here we go. When finding the midpoint of 2 points on a graph, add the two x's and cut their sum in half. Add up the y's and divide them by a 2. Now write them as an ordered pair. You've got the middle of the 2. See? It's not bad. All right. So, one free homework pass. Have to have it memorized, have to sing it. You can get up in front of the class in groups of 2. If your partner wants to do it with someone else, that's fine, but they still only get one math card for the formula, okay? So that's the rules. We will do that on Thursday at the beginning of class. So got a couple of days. I usually like to give you a weekend, but we just didn't work out that way this time. So a couple of days, study it. We'll do distance formula in a minute. Okay, back to our notes. You ready to practice the midpoint formula? These start off easy and they get harder as we go depending on what they give you in the problem. This first one is really simple. It just says find the coordinates of the midpoint of line segment PQ if they give you the endpoints P and Q. So basically they're giving you each endpoint and they're just simply asking you to find the midpoint. So all you have to do is average your x's and average your y's. If I were you, I would write my midpoint formula down just because I'm trying to memorize it. And the more I write it, the more I'm going to memorize it. But then you can just plug in your values. So what am I plugging in for my two x's? -8 plus -2. Really, I don't need plus or minus. It should just really be -8 minus 2, but I'm going to put it there just to make sure you understand that you are adding in the formula. Divided by 2, what's going in for the y's? 3 and 7. So 3 plus 7 divided by 2. All right, what is -8 plus -2? -10 divided by 2. And 3 plus 7? 10 divided by 2. So what is my coordinate for my midpoint? -5, comma, +5. Good. Make sure you put it in parentheses so that it is an ordered pair. Easy? All right? Yes. So then they get a little harder because now when we read this one, it tells us that M is the midpoint of XY. And notice that it tells us what X is, but it doesn't tell us what Y is. Instead, it gives us what? So it tells us X has these coordinates, but then it says M, which is the midpoint, has these coordinates. So this time they're giving us the midpoint. They want us to go backwards and figure out the endpoint Y. Okay? So I'm going to show you two ways you can do it. One way is with algebra. So if you're an algebraic person, you love it that way, I'll show you that way. Second way is graphically, which means you would need graph paper and you could do it that way. I'm going to start with the algebra way. It's probably the harder way, but I like it because sometimes if you choose the graphing method, if your numbers aren't very nice and they're bigger, then it's a lot harder to graph it because you've got to go to your graph paper and make it really far out. So algebraic way, we start with our formula. M equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Then we're just going to plug in everything we know. What is our midpoint M? 6, 1. So in for the capital letter M, we're going to put 6, comma 1 equals. Remember that x1 and x2 stand for the x's of your endpoints. You only know one of your x's. What is one of your x's? 2. So you're going to plug 2 in for one of these x's, and then you're still going to have an x in your problem. And you can call it x2 if you want to still, but there's only one of them left, so I'm just going to call it x divided by 2. Is everybody following me there? And then we go to the y1 plus y2 over 2, and we know one of our y values is what? 7. So we're going to put a 7 in for one of them, but we're going to solve for the other one. So we substituted our midpoint, substituted in one of our endpoints, 2 and 7. Now look at what you have. This ordered pair should equal this ordered pair. If that's true, then the part that comes before the comma should equal the part that comes before the comma. So what you can do is write two separate equations. One for the part that comes before the comma, and then a second equation for the parts that come after the comma. In other words, I can say 6 should equal 2 plus x over 2. Does that make sense? And then you would solve for x. Stop for a second. I'm not going to solve that yet. Let's write the second one that we could write down. So now we're looking at what comes after the comma. 1 should equal 7 plus y over 2. Making sense? Okay? And then you just have to go through and solve for your x and your y, and those will be the coordinates of your final endpoint. So what would I need to do to solve for x? Multiply both sides by 2. Good. So if I multiply both sides by 2, the 2's cancel on the right, and we end up with 12 equals 2 plus x. Subtract 2, and what is our x value? 10. Then we're going to do the exact same process over on the other equation to solve for y. So again, multiply both sides by 2. That gets rid of that denominator of 2. And we end with 2 equals 7 plus y minus 7. And so what is y? Negative 5. Your answer needs to be written as an ordered pair, so we're trying to find the value of the coordinates of our capital Y, which is different than this lowercase y. Capital Y is the end point of this line segment. So our coordinates for capital Y are 10, comma, negative 5. So harder, but not bad, right? Just some simple algebra. Okay. Let me show you the graphical way. So I'm going to grab some graph paper and pass it out to you. When we take our tests in here, you will be allowed to have graph paper anytime that you want it. So if things become easier for you by using graph paper, just let me know. I'll pass it out to you so that I know it's clean and fresh and there aren't any notes written on it. But if you want graph paper for your homework, here's what I would suggest. Before you leave today, please don't grab the entire stack. But before you leave today, grab 3 or 4 sheets of graph paper back there and stick them in your binder. And then if you use a couple of sheets of paper on your homework, the next time you come to class, when you turn it in, grab a few more and put them back in your binder. You don't have to go buy your own graph paper. I have it back there. Just make sure you keep some because I'm not going to warn you when you need it on your homework, okay? So it may be that it's the night before and you're stressing out. If that happens, if you have a printer at home, you can Google graph paper and print out graphs, or you can run to Walmart and buy graph paper. But I do not want you to hand draw your graphs. So you could rip out that page and do it on there if you prefer to do it that way, or you can do it on the graph paper that's in the classroom. Okay? All right. So here's how we could work this on graph paper. So take your graph paper with me. Let's plot the 2 points that they gave us. And so I'm going to just hand draw mine up here, which won't be as pretty as yours. We're going to graph the point X at 2, 7. So here's X, and then they gave us the midpoint was at 6, 1. And we want to find the other end point. So keep in mind, M is supposed to be in the middle of your line segment X, Y. So what quadrant do we know for sure by looking at this Y has to be in? 4, because if I try to draw a line segment from X to M, I know that it needs to go the same length across to get to Y, right? So I can just use the concept of slope. I can simply count the distance from X to M and then just repeat that slope. So if I do that, how far is X down to get to M? Everybody agree? Okay, because I'm going from 7 to 1, which is a distance of 6. So I'm going to go down 6, and then how far do I go right? 4. I'm going from 2 to 6, so that's 1, 2, 3, 4. So I'm going to go down 6, right 4. So from here, I'm going to go down 6, right 4. So down 1, 2, 3, 4, 5, 6, and then right 4. And then look to see where it lands. This was at 6, 1, so 7, 8, 9, 10. And when we went down 6, we were at positive 1. So when we go down 6 more, that lands us at negative 5. And so we end up at 10, negative 5. So I think graphing's easier when your numbers are nice and small, but if the numbers are really large, like negative 53, you probably won't want to have to graph that on a graph paper. And that's where the algebra method then makes it a little easier. Are we good? All right, awesome. You guys are doing really good. It's going slow again. I am. This is new, and so I think this right here is what's messing me up. This didn't used to be here last year. It was these little things down here. So I don't know. This is like just a lot slower. Something to do with my PowerPoints, and I don't know why. Okay, so now we're going to move on to the distance formula, our second formula for today. I want to remind you that we have already learned one distance rule, and that was when we were on one-dimensional distance on a number line. And if you wanted to find the distance in one dimension, you did the absolute value of the difference of the coordinates. You guys remember that? So if it's one-dimensional, you just subtract the two coordinates, take the absolute value. If it's two-dimensional, so now we're back to a coordinate plane and we're trying to find the length of this line segment, we can use distance formula. I also do want to tell you that you could make a right triangle and use Pythagorean theorem, which we're going to look at that method last. But you are going to be required to know the distance formula. So when it doesn't specify how you have to do it, you get to choose. But you will be required to know your distance formula, so make sure you can do it both ways. And on the homework, I think there is at least one problem that actually asks you to solve it with distance formula and then with Pythagorean theorem. And you should get the same answer, but you're going to have two different methods on your paper. Does that make sense? Okay, and I'll explain when we get to one like that. So here is your distance formula. You're going to need to memorize this. The most common mistake with distance formula is that you have the idea in your head that you're adding your x's from midpoint, but you are not adding the x's with distance. You're subtracting them, right? I'm going to explain where this comes from by using the Pythagorean theorem and go back to this picture. Okay? So, if you'll bear with me for 1 second and look up here so I can explain to you where this distance formula comes from. We already know. Oh, so sorry. Mrs. Lashley. It's okay. Yes, ma'am. Yes, ma'am. Thank you. Bye-bye. Adelina, ride bus 16 home today. Okay. All right, so back up here. You can use Pythagorean theorem. We've already talked about it in here, reviewed Pythagorean theorem. Remember that it only works for right triangles. So what you can do on problems like this is you could draw a straight line vertically down and horizontally over and create yourself a right triangle. If you do that, then you have A, B, and C, and you can use A squared plus B squared equals C squared. Okay, what I'm going to do is use those same coordinates that we were just talking about. This is x1, y1. This is x2, y2. And I'm going to talk about distance in one dimension like we talked about the other day. So let's talk about just this vertical distance. Just going down here. If I'm looking at the distance vertically, then I'm looking at the y value here compared to the y value here. Would you agree this is y? Y, we're looking at the distance in the y's. And my rule that I learned the other day was to find this distance, I would do absolute value of y minus y. Or in this case, y sub 2 minus y sub 1. Would you agree that that one dimension vertically down would be the difference between this y value and this y value? You guys following me? Okay. Same idea over here on the horizontal distance. For the horizontal distance, I would be looking to see what's the difference between this coordinate and this coordinate in one dimension. And so that's the x1 and the x2. So it would be the absolute value of x2 minus x1. One-dimensional line, distances, subtract them, take the absolute value, right? Okay, so I'm going to plug those values in for my A and my B into my distance formula, or my Pythagorean theorem, sorry. So in for A, I'm going to plug in this. y2 minus y1, that's the distance of A, and I'm going to square it. For B, I'm going to plug in this distance. x2 minus x1, and I'm going to square it. Equals, and then c squared is this length that we're looking for. We're looking for c, but the Pythagorean theorem says that this is equal to c squared. So I'm going to leave it c, just means we're looking for this distance right here, squared. You'll have actual numbers that are going into your formula. It'll be like this, except you'll have a number and a number. Okay? What does absolute value do to a number? Makes it positive. What happens when you square a number? Okay, so if I have a negative number and I square it, what does it become? Positive. If I have a positive number and I square it, what does it become? Positive. So would you agree that since I'm squaring this, I really don't need these absolute value signs anymore because it's going to be positive anyway? Okay, so I'm going to delete the absolute values now. And then I have one more thing to do. All I need to do is I'm trying to find c, not c squared. So how do I get rid of a square if I'm trying to solve for just c? Square root. And so then we would take the square root of both sides. And so the distance formula, or the value of c in this picture, which is the length of that line segment, would be equal to the square root of y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 squared. Does it matter the order in which you add two numbers? No. So I have y2 minus y1 squared, but notice in the formula they have x2 minus x1 squared first. The order doesn't matter. So that is how they came up with the distance formula, using Pythagorean theorem and the idea of one-dimensional distance. Okay, so what you have to memorize is this distance formula. This will calculate the length of a line segment in 2 dimensions. You're going to subtract your x's and square them, subtract your y's and square them, add them together, and then take the square root. Does that make sense? Okay, so now we lead to the distance formula on your paper. This one is a little harder because it's slow, and it's to the tune of On Top of Old Smoky. So I'm going to play you, first of all, so you can get the tune because I can't carry it very well. Okay, let me pause this first.